So Gerson and Cora and Donnie, you are in the same group?
No.
So anyone is interested today to present?
Should we start, Cora? I think we're the only full group here technically, so.
Yeah, go ahead.
All right, let's see if I can share my screen here.
Yeah, you have the privilege to do this.
Okay, you should be able to see our, oh, that's. All right, Cora, I'm pretty sure you're starting us off, so whenever you're ready.
I will mute myself, so you will take care for this. You can start if you want.
Are you ready, Cora?
Yeah. Okay. So, good afternoon. We're group 4. So, Connor and I'm, our selected project is the Jump It game. So, the Jump It game. So, the objective of it is to start from the space on the left to the very left. You must travel from Oh, okay, sorry. Hello, do you hear me?
We can hear you now.
Okay, sorry. From where you don't hear me, from the start or from?
You can start talking from your objective now, this slide one.
Okay, so we selected the Jump It game. Then the objective of it is from the start position at the space to the very left. You must travel from one end of the board to the other. Each turn, you can either jump 1 or 2 spaces to the right. So at the end of your turn, you add the number in the space you landed on your total score. Until you reach the final board space, keep taking turns trying to get the lowest score as possible. So, Connor, can you move to the next screen? Yeah. Okay. To the next slide, I will discuss the process flow. So, it's so small, but okay.
Everyone, if you want, I have it here as well.
They have the bigger. Okay, I'll check my. Okay.
On documents, here we go.
Okay. I have here also. Okay. So, we created 3 function. So from the start, this is the main function. From the start of the program, we set the play again variable as 1. So it automatically call the first function, the jump it game function. So it print the rules, it display the rules, request the user to input the board size. Then the program will generate a vector. Then basically the jump it game, the user will input the larger value. Then from there, it will call the second function, the number gen function. So this function will generate the random number. So basically, that function via generate the example from the the board size. So if the user select 5, so it will generate 5 random numbers. So after that, it will print to the screen the generated random numbers. Then the user or the player will input the guess total lowest cost or jump. Then after that, the program will call the third function the route optimizer function. So in this function, this one, this function compute the lowest cost or jump done, and it also compute the difference between the correct answer versus to the answer of the user. Then it will return to the jump it game function, and from there the user will ask if he will play again or exit in the program or exit in the game. Then it will return to the main routine, and it will end print a message, then it will end from there. So that's the main process flow of the Jump It game.
Yeah, so that explains the flow chart we made. For the actual code of it, we had two different possible solutions. The first one was, it was the first one we thought of here. And the original solution was actually, we were going to start at the initial spot, which is always equal to 0. And we'd check whether one spot over or two spots over had a lower value. And then just doing this repeatedly until the end. The thought process was, well, if you always make the jump that has the lowest cost over and over, you're going to get the lowest possible value. But there was a flaw with this one, actually, is it couldn't find the shortest route always. And this is because sometimes you want to choose a jump that will have a higher cost initially, but it'll give you access to skip some other spots that have higher costs that are close to it. And it'll actually get you a lower cost for the game at the end. So we have a bit of an example here to show it. Well, an explanation of the new solution first. So how we did this is we would actually start at not the first number, but the second number, and we'd look at the two spaces behind it. Looking at these two spaces, we were able to see which, if we were going to go to that number, the second number, which was the shorter path. Was it going from the first number or the number 2 to the left of it, and then going to this spot, or 1 to the left of it? And by doing this over and over for every number, and then taking the number, the total number for the shortest path, and putting it into the spot in the vector, we could then find the overall shortest path. And I have an example to show with this, just so it's a little easier to understand. Here's an example of what our old solution would actually get versus the new one. So I'll use my mouse as a pointer here. The old solution would start here and would look at these two values and say, okay, well, in this case, they're actually the same. So the code would say, okay, we're going to go here. And then from there, we're going to compare again with these two. 3 is smaller than 13, so it'll jump here. And it does this so on and so forth until it gets to the 12th spot or 17th spot. And when it sits in in a spot where it can jump to the final placement in the board, it'll automatically just do that instead of calculating that, because it's pretty irrelevant. But these were the two different answers we got. Was for the first original solution, which would just be comparing which of these two is lower. The shortest route was outputted was 61, but this isn't true. It was actually found that the shortest route would be 52 for this. And I've got an example here explaining kind of how our second solution actually solves this. So it starts by looking at the second variable, and then it'll look 2 back. So it's going to check, okay, 1 variable to the left is 9, and then 2 to the left is 0. So since 0 is smaller than 9, it's going to add 0 to here, and then it's going to change the number. So 0 plus 9 is 9. So it leaves that, and it moves 1 over. And it repeats this process over and over, doing this all the way to the end. So the actual vector we get changes completely into the answer in the box will become equal to the cost, the lowest cost to get to that spot. And since we keep doing that every time, when we move one spot over, it's going to say, okay, the lowest possible cost to get to this box is 9. The lowest one to get here is 12. So it's going to add 9 to this spot, because we know that this box is equal to 13. And if we make 2 jumps from here, the lowest possible cost here is going to be 13 plus 9. So it does that to the end. And the answer found was 52 here. So let me just open this back up here. And here I've actually going to give a live example demonstration of what this the game running looks like here. So let me just boot this up real quick. So here's our game. I'll zoom it in a bit just to make it easier to see. So the example I always recommend to start with this, or I have been testing for myself, is having a board length of 10 and making the largest possible value 20. You don't want it too large, just because it just becomes very annoying adding up all those numbers. But it'll actually print the board here. And then as Cora mentioned, it'll give you the option to answer what you think the lowest possible value is, because it's supposed to be somewhat of a game. So I thought, you know what, why not let the player actually join in? So you can put in an answer here. And I was actually going to ask if anyone had a guess of what their lowest possible cost to solve this is. We can see how accurate they are. If not, that's fine. I could just enter one in here as well. Let's see here. I'm thinking it's going to be... thinking it's going to be this. Well, this will be my guess. And there we go. So I did get the right answer here. And then, yeah, as Cora mentioned as well, it asks you if you want to play again. 1 for yes, 0 for no. 1 will just repeat the actual function itself, so we won't do that. We'll just press 0, and it just gives you a nice message. See you next time. And depending on how close you are, actually, it'll give you different answers. So if you're within the range of 2 or 3, it'll say you were pretty close, you're off by this much, you know, maybe you'll get it right next time. And then if you do really bad, it'll say maybe you need some practice, which I thought was kind of funny. So we can close that here, open this back up. And besides that, yeah, that was basically our presentation. We feel like we explained the code itself very well. And we were wondering if anyone had any questions.
Guys, thank you so much for your presentation. It is an amazing project. As a Comp 152, which is an introductory programming course, I expect a level of difficulty less than this, but you did good job. So I'm glad to see this, and I'm happy to see this. So before I ask my question, I will keep, listen if somebody of the people who are here want to ask you a question. Go ahead and ask them a question, don't be shy. Donnie and Kerso, maybe, Avi, do you have any question you want to ask them?
No, I don't got any, it looks really good.
Okay, so Kirsten, I have a question for you. Based on their presentation, you can understand the way the game it works, or you need more?
No, they explained it really clearly. So
okay,
that was like really good.
Thank you. It's good to know. We're concerned about how clear it would be, the explanation. It's hard to explain code in layman's terms sometimes.
Yeah. I was struggling with that too in our presentation.
Looking at the chat, it looks like Donnie has a question here. I'm not sure exactly what he's asking though. Why don't you use BFS first C?
Donnie, can you clarify it for them what you mean by BFS? Donnie, maybe he doesn't have a mic, but he will going to type what you want to ask. Yeah.
I'm not gonna lie, I haven't heard of breadth first search, so that's probably the reason why I didn't use it.
Yeah, Donnie, they will take it more in course, we name it here algorithm and data structure in the university. So in this course, you will learn more about algorithm and data structure. It is 200 level course. They will learn different kind of algorithm in this course. This is why I said at an introductory course, it is more than expected. Okay, let's me start. I will first give a feedback, and again, this feedback will not affect your grading, so don't worry about it. But I think that I have to give a feedback. It will be more than advices, more than it is a feedback. Which means first, let's talk about the presentation. Normally, when you are going to present any project, before you go to the technical part, you have to talk about the problem statement or about what is the aim of this project or the topic of this project that's talking about. And at this level, it would be very nice to use some graphics. Don't put a paragraph like this that describing the whole project, because this is not a report, it is a presentation. And now when we talk about a report for technical people that are going to make an assessment, so you can write an essay or paragraph. But when we talk about a presentation for audience, that these audience, they are hearing you, and at the same time they have to concentrate in the presentation. So try your best to have less text, more figures. For example, I would suggest that this jump in, you can find any infographics pic talking about this jump in while you are talking about it, and try not to have a paragraph, put bullets highlighting the main topics or main issue in your project. In this, you can help your audience in a better way to understand, and in the same way to concentrate between what he is hearing and what he can see as a textual content for the presentation. What do you think, Connor and Cora?
Yeah, that makes sense.
Yeah.
I kind of try to do that in the end with the example in the Word document that I showed, but we probably should have done more of that. Yeah.
Yeah,
Okay,
I think
and
more graphics
go
is
ahead.
more helpful. Using graphics is more helpful to understand the
Yeah,
process of
and
it.
there is another point concerning presentation. Normally, when you make a presentation, people don't expect or they don't know what you are going to present for them. So it would be very nice if you have a very small outline that give me, after you talk about what is your topic talk about, what is your subject, and give me some motivation and let me more excited to know you, to know what you are going to say. And then you will give me, let's say, an outline. And later when you go with your presentation, in my mind, I am not arranging the flow of data because you have already given me as a predefined outline to follow it up with you. This will help also your audience in this case.
Yeah, we actually, that's funny because we wrote out how we were going to make the presentation slides on paper. We're going to say we're going to do this, 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 and this, and this. And I didn't even think about making a slide showing that because it would definitely make it easier for someone to follow along. That's a thought to keep in mind here.
I'm giving you my feedback from the audience perspective. So what will be the best for your audience, because the challenge in any presentation, how you can attract the audience, how you can hold the whole, let's say, the attention of the audience, how you control it, and you go ahead in a way that you will always be sure that the audience is concentrating with your content in order that later they will benefit from it or they will give you a positive feedback. Now, concerning the flow chart, I like it so much. This is the best way when we talk about an algorithm, how that if you are going to make a flow chart that you have already done, this is perfect. It was very nice to do this, because this will, rather than opening the code for us during the presentation, I can understand the hierarchy of your algorithm. And again, later during your program, I don't know each one of you in which program, I thought there is another course named Algorithm and Data Structure. You will learn more about algorithm structuring during this course. So, but another, let's give you a feedback about presentation that you can help you in future presentation. When you have a huge flow chart, it would be nice to make it as animation, because it's very huge one. So if you give it, you are going to make it as you have done in your cases. You have to go to have another version for it, to have it more clearer for us. Even though if I see the whole flow chart as a one shot, maybe okay, I will try to understand what I'm talking. But if you give me part from it, and then you finish discussing this part, and then you have another part from it. So breaking down a huge flow chart for different parts and make animation that only show the audience what you are discussing now it will be good. At the end, you can go ahead and present the final version in this case.
We had that plan for our presentation. I think what happened though is we couldn't get a good photo of the flow charts that we made in the program we used. So we had them on our slideshow, but Cora kind of mentioned it was pretty hard for her to like see it and read it. So we just had to take better photos next time, and we could have done that.
Yeah, this is the point. But even though it's somehow clear for this, but I'm talking about the animation, which means that even though you have a good resolution for this, but if it will be a longer chart and you are presenting it, go ahead and break down different part and give now the part that you want to talk about it. You finish, then you go ahead and make another part with it. It will help the audience more to follow up with you in this case.
Oh, do you mean like having it so it shows what you're talking about, puts the next thing you're going to talk about over? Okay.
Yeah.
Okay, that makes more sense. Yeah.
Yeah, this will help the audience more understand the flow of the data or the flow of your work that you are talking about. Because maybe if you give it the flow chart as a whole, so maybe I go ahead, see the end of this algorithm for you, because I am somehow more excited to see what will be the final output, and you are talking at the beginning now. So go ahead and focus more about the part that you are talking about and make animation, which means each time either we will highlight the part that you're talking about it, or maybe you have already made the other part invisible and make only the part that you are talking about it now visible, using the animation tool that you can find in the PowerPoint or another program that you can use it. I'm just giving you hints about presentation because I said the aim of making presentation, it is the first one to be sure that you have already done this. Plus, it will make a practice for you because you as a software developer, as an engineer or a software designer, whatever you later are going to work, you should know how to present what you have already done.
Yeah, I wrote them down here because I imagine we will both have to give presentations in the future. So I'm going to be going into science, so I won't have to worry so much about the coding aspect of the presentation, but I have to worry a lot more about the making sure it's very understandable. These are going to be things that I've spent, a long time learning that other people aren't going to know about, and I'll have to quickly explain them and move on from that. So thank you for the pointers. That's very helpful here.
Thank you for the feedback. Thanks.
Yeah, now you mentioned that there is an old and a new. What do you mean by old and new? That you have started with one, then you have changed it?
So we originally, our plan was for solving the problem was we were just going to start with looking at the 0 spot or the index 0 in the vector, and then we were just going to check the spot to the right and then 2 to the right of it to see which one was lower. Because the original plan was, okay, well, if you always just choose the lowest cost jump you can always make, you'll probably be able to get the lowest score possible. But testing that out and having some friends and family try it out, we found that their guesses were actually better than what the code did. So then we worked on it for a little while and fixed it. And we found, hey, if you started the second number and look backwards instead of starting at the very start.
You share your work with your community, with your family, with your friends, somebody else, you ask him about the feedback?
I had my sister and mom play it, and then I also had a friend of mine play it just to see if the instructions were good enough to read. And then also to see if they could get a better answer, just to test if it was working. Because I don't know, writing the code yourself, you're like, oh yeah, I understand how this works, and you always just are waiting to see a certain answer that you think it's going to give, and if that's the answer it gives, you're like, okay, this code works. But having them try it and give better or worse answers, it was interesting to see.
That customer feedback, suppose that there are customers, a user of your software, it is a very important parameters. And nowadays, the software development cycle, the modern one, like the Agile one, they will focus more about customer feedback in different phases. We are talking about a huge software. So I think that later also in the university, we are going to talk more about software development cycle, about analysis and design for software. You will learn more about that when you develop a software. The customer feedback, at an old-fashioned one, the customer feedback will be at the end. When you finish your software, you will go, okay, to the customer, is it what we have already? Is this what you expect from us? But however, for example, the modern one will say no. In each phase of your work, the customer feedback should be involved. Because you, as we said, you as a programmer, you can see the whole image. For you, you have done a perfect work, but you still need a user feedback that will help you in this. Good approach. The last question for me, then you use a vector if there is a reason that you use a vector, even though the size is a predefined size?
The size isn't predefined for our array. We have it so you can choose how large the game is. And then the largest value, Cora talked about this a bit, is basically the largest number that the board can have in it. So it's making it so you can, you can change the difficulty in someone. You could have a game that's 100 spaces long, and the largest number is 9,999. I don't think I'd want to play that because the amount of time it'd take to play that. But we made it an option because, I mean, we had some spare time.
The reason was to have a flexibility with the size.
Yeah. So originally it was just kind of figure out how to actually, I think I designed that for the beginning. Was I kind of want the board size to be any size because you didn't specify in the code what size it had to be. So I thought, well, if there's a way you can make it without needing to choose a specific size, why not? So yeah, we included that as part of it. Is you can choose any size, and that's why we had to use a vector instead of an array.
I see. I'm done with my question. I want to say you did a very nice work. You will have a nice grade. So my question was just more feedback and to help you enhance the way you present your work. I like it so much, and I'm happy to see this. And I hope that later we can meet as a campus. Maybe next semester will be as a campus. We still have some online courses, but there are more on-campus courses comparing to the online courses next semester.
Yeah, I think I'm going to send you an email about this, but I'm trying to figure out things I can take as electives in the future because I've got most of the classes I'll be taking are sciencey, and I'm not that interested in things like
What
arts.
is your program?
I'm going to be going into a bachelor's of science. I'm hoping to get into a physics major. That's the goal.
Okay. So you're not computer science.
No, I'm not going to be going in there, but I've heard it's very helpful.
You will be a nice programmer.
Maybe. Well, I heard that it's very helpful for what I'm going into. So I'm thinking I might just take some of these courses on the side while I'm going through it. Because I want to have at least 4 courses a semester, and I can't do that all the time because of the way math and physics courses line up. And B, it's just another skill I could learn. So
yeah, it's up to you what will be your future career, what you imagine will your future career work. But me as a person that have maybe more than 10 years giving online, giving university courses and work with industry, I can see you will be a good programmer. So I will advise you shift to computer science. But knowing that people will be in computer scientists that later have to deal with the software, they have to deal with different sciences. For example, I have to work with industry with a quality management solution. So I have to go to take many courses concerning business management and quality management to understand how to deal with this different courses. And I have been working with data science for a long time, making research on this. So I have to deal with, for example, many medical records, mining, and different stuff like concerning science of medicine. So being a computer scientist means that you are going to deal with different sciences. But you should take care about what will be your next career, because if you will be a Bachelor of Science, for example, in physics, you will have a limitation in the career later. You should know about this.
Yeah, that's not where I'm planning on ending. That's just what I'm currently going for. I don't know if I'll be able to actually get there, but I'm hoping to do something along the lines of teaching or research possibly. It's quite the goal for someone, just entering into technically their second year of university. So we'll see if I can actually get there. But one of the big suggestions I heard was taking programming courses with the Bachelor's of Science because it's a good gateway to get into other jobs. And I definitely do enjoy programming. It's a little difficult for me from doing math solutions where you have to make something that generally starts at the beginning and goes to the end, and you have to use like a very specific formula to solve something versus you can kind of just go like this one. It was a bit tricky for me to think, okay, well, let's start at the second number instead of starting at the first one. And there's a lot more freedom in problem solving here, which it's definitely interesting to see, but it's hard for me to get used to that different style of thinking there.
I don't know, but I can see that concerning problem solving, which is the mathematician has to deal with it, and also computer science. By the way, a long time ago, about more than 20 years old, if we go before this, the computer science was apart from the mathematics department. So it was not a standing alone subject. So it would be under mass, and it was minor as a computer because when I'm talking about maybe more than 20 years, maybe 30, 40 years ago, and still there are some university they have mathematics and computer science as one department because they believe that being a computer scientist you should have a very solid mathematical background, because especially what Donnie has told you now about different algorithms. Later it is the same solution. You can have the same problem, you can have different solution for this, but now the big question said which one the best. When I said best, based on efficiency and effectiveness. So we'll go to estimate the complexity of the algorithm based on different mathematical notations and formula. And for example, in my case, my PhD was about machine learning, so it was more mathematics than it was more computer science. If you can see my PhD now, there's a lot of formula there. You can see it is more math more than it is computer science. So computer science as a topic, it had a huge overlap with the math.
Yeah, I wasn't trying to say they were different things. How was I? Basically, what I was trying to say is, from what I've experienced so far in math, you kind of have one way you often look and solve at a problem versus having so much more freedom for the problem solving. I definitely like the problem solving part of it. It's just harder for me to get used to you don't have to do this from the start to the end. You can start here and you can do this. So you can, you're allowed a lot more freedom when you're solving a problem. So
yeah, I agree. Okay, guys, Donnie and Kerson, are you going to present something today?
Well, I came because
go ahead.
Well, our no, I mean our group already recorded a presentation. I didn't know if you were gonna like watch them on the
yeah, sure,
like in the live session, and then you had questions or something. That's why I came, just in case like you guys had questions or something.
No, I don't have enough time because today is a deadline, so I will start and make the assessment and correcting and watching the videos and the deliverable after the deadline. So I will that everything is being delivered.
I see. All right, sounds good.
So today it was just like what happened with Connor and Cora. So it will be an open space to people is going to present their work to others, like what happened with them.
I mean, I do have I have the file.
I understand. So it's up to you if you want to present it or you are satisfied with offline recording that you have already done.
Yeah, no, I have a recording. I can just share my screen, I guess, if you want me to. I can do that right now if you want.
It's up to you. It is an open space today for you.
All right, sounds good. I'll do it. Okay. Screen. Where is it again? Wait. Oh, this is the wrong one. Files. Okay, wait 1 second. Let me find it. I don't know where it is. Where'd it go? Oh, I was in the wrong group. Okay, here it is. Here, I'll share my screen now. All right, can you guys see it?
Yeah, you can see it. We can see your screen. And it is more video on you, maybe. Yeah, go ahead. But you should know that if there is an audio that we can't hear the audio, you have to talk in this case.
Oh, okay. Well, I'm not. If you guys can't hear the audio, then it's probably not a great. I haven't like practiced presenting or anything, so.
Don't worry about it.
Okay.
No, it's okay. Okay, so if you don't want to, if there is no any more project presentation, let me talk more about the final now.
Okay.
So the final, it will be very similar to the assignment. You have 3 hours. It will be using Blackboard. So the same like when you have an assignment, you can go ahead and double check it in the Blackboard. So the final exam will be there. I'm almost done with it. So there is a part concerning multiple choice and true false. It will be more a general and conceptual one. And there is another part about coding one. For sure, it will not be like the project one. It will be smaller comparing to the project for sure. And it will be more, it is more specific one. And in this case, you are going to write piece of code, but very specific one. The level of difficulty, it will be almost like the assignment. So you will not expect to see something very new and also if you have already practiced all the material, I'm quite sure you can have a nice grade. So if I want to make an evaluation for the level of difficulty, I can see it is in the middle. So it is not very hard one, it is not very easy one. I try my best to go gradually in the level of difficulty of the question so that most of you can pass the exam, but who has practiced more, they can get an A grade. So the exam will be an easy one, as I said, and it will be similar to the assignment. All the material is included. We can't say that there are some material cannot be included. So this is what I can share concerning the final. And I want to give you an advice. Don't go ahead and search for multiple choice and true false and waste your time, go double checking to see if, because many students will expect that since it is an online exam, they have to do it at home. So, okay, whenever there is a multiple choice true false one, they go ahead, copy the text, search online and try to find a solution for this. However, this is not the case because this will be time consuming and maybe if you think about it, you can find the correct solution in a very faster way and a very better way in this case. Do you have any question for me concerning the final or the course or concerning, or you have a feedback you want to share it with me? I'm happy to hear you today.
Are you teaching the Computer Science 155 next semester, or is that like someone else?
You mean the object-oriented one?
Yeah.
Yeah, I'm giving it. It will be also online.
Oh, okay, sounds good.
But the capacity of the course is 35. We have almost now 35 and 15 students in the waiting list.
No, I already signed up for the class, so we're good.
Perfect. So then we can see you in the next course in this case.
Yes, sir.
Okay, do you have any more questions or feedback for me? I'm happy to hear. If not, then like always, I need 2 thumbs up to leave today.
I had a question actually.
Go.
For my assignment, my redo assignment, did you get my emails for that, or because I emailed them
I replied all the mail. When you sent it the last week, I should have.
Yeah, last week or something.
Let me double check now. The last email, yeah, the finished assignment. Thank you for again letting me on. The last email from you, it was 28 October. It was about assignment. Yeah.
Okay,
28 November, sorry.
Yeah,
I got the files.
Okay, awesome.
Maybe I haven't replied because there's no action from my side. So, but I have received it.
All right,
and I will re-update the grade as we have already agreed.
Okay, sounds good. Thank you.
Don't worry about it. Connor, go ahead.
I had a similar question too. Did you get my assignment 3? I remember I emailed you about that. I completely forgot that it was due at the end of last month. I handed it in 2 days late.
Don't worry, yeah. Yeah, I have already replied to you. And you
I just wanted to make sure it went through.
Yeah, you didn't send it. I replied to your email and then you said okay. And I just handed in the assignment. This is the last email between me and you, yeah?
Yeah. I just want to make sure it went through. I don't know how marking for Blackboard works. Some places, like if you...
No, I haven't marked assignment 3 because, to be honest, I was more occupied with the final exam preparation. So I'm almost done with them, with all courses. So next week I will start publishing the grade.
Okay. Thank you.
Don't worry, when I publish the grade, I will send email for all telling that I have already published the grade. But expect the grade will be next week.
Okay, I'll keep that in mind. Thank you.
Yeah, sure. Okay, guys. Then if there is no any more question, I need thumbs up. Okay, perfect.
Have a good day.
You too. Enjoy the rest of the day. Take care all.